Today, in this part of the video, we are going to deal with indefinite integration part 7. Before we exactly get into the indefinite integration of part 7, let us have a quick recap of all the formulae what we have studied so far. So, these are all the formulae what we have done so far. What I want you to do is go through these formulae thoroughly well and be perfect with these formulae as well as the special functions. So integrations of these special functions are also important ones which you have to remember. So that can be done going through this set of formulae by pausing the video in between. So with the help of these formulae and special integrations, we will get into some other types of integrations. So integrals of the type px plus or minus q upon ax square plus bx plus or minus bx plus or minus c dx, and the same expression in the denominator with a square root. So what we find in these two expressions, in these two types, is numerator is a linear polynomial and denominator here it is a quadratic without square root, and here it is quadratic with square root. So in such cases we have a simple method that we adjust the numerator in terms of the derivative of the denominator. Denominator means this quadratic polynomial, not the whole denominator, because here you got square root. So we adjust the numerator in terms of the derivative of the quadratic polynomial and a constant, that is px plus or minus q equal to a times d by dx of ax square plus or minus bx plus or minus c plus b. And here a and b are the values which we have to find out. And to get these values, what we have to do is we have to simplify this, rearrange the terms, and then compare the coefficients of like terms. So in the first part, what we find is the derivative of the denominator and the numerator. So this can be easily be solved by substitution method. And the second part is solved by completing the square method. That is what we have done so far in the previous example. Rather, previous video, you can refer to it. So let us consider the examples based on the information what we have studied so far. So these are all the problems where we find the denominator is having a square root in some cases and some cases without square root, and quadratic polynomial. This is a special kind. We will understand this when we solve this. So first one. So here what we have is 3x plus 2 upon 9 minus 4x square. So 3x contains the coefficient, contains the derivative part of this x square. Derivative of x square is 2x. It has got x. So that means this can be easily be adjusted. Observe that there is no x term in this denominator. So we separately divide by denominator. So it becomes 3x upon 9 minus 4x square, the first part, and second part is 2 upon 9 minus 4x square. And take separate integrations. And next is we adjust the derivative of the denominator over here. And in the second part, we put it in the form of a square minus x square form. So here what we have done is multiply it by minus 8. So it becomes minus 3 by 8 integration minus 8x upon 9 minus 4x square. So the derivative of this is minus 8x. And here we have written the same expression in the form of a square minus x square. So directly we get into the solution, that is equal to minus 3 by 8 log of denominator, first part, plus 2 times 1 upon 2a log of a plus x upon a minus x type, into 1 by 2, this 2 because the coefficient of x. So finally what we get is I equals to minus 3 by 8 log of 9 minus 4x square plus 1 by 6 log of 3 plus 2x upon 3 minus 2x plus c. So here we have 5x minus 1 upon 3x square plus x minus 2. So we have got x term also in this case, and we make use of the method. What method says is 5x minus 1 is written as a times the derivative of the denominator plus b. So that gives you 5x minus 1 equal to a times 6x plus 1, the derivative of this, plus b. Now open this bracket and simplify. We will get 5x minus 1 equal to 6a times x plus a plus b. And now we compare the coefficients. So on comparison we find 6a equal to 5 and a plus b equal to minus 1. So that gives you a as 5 by 6 and b equal to minus 11 by 6. Now substitute these two values in equation 1. So we get numerator part, that is 5x minus 1 as 5 by 6 times 6x plus 1 plus of b value is minus 11 by 6. Therefore, the problem changes to integration I equal to integration of 5 by 6 times 6x plus 1 minus 11 by 6 upon 3x square plus x minus 2. And again here we separately divide by the denominator and take separate integration. So in the first integration we are going to substitute, and for the second integration what we have done is I have taken 3 out here. When 3 goes out, it becomes x square plus x by 2, x by 3 minus 2 by 3. And then this part is written in the form of 2ab. So it becomes a square plus 2ab plus b square form. So 2 into x into 1 by 3 becomes 1 by 6. So b is 1 by 6. So b square is added and b square is subtracted. So that means what I can do here is multiply it by 12. So it becomes 24 by 36. So it becomes minus 25 by 36. Rest of the part is written as it is. So 5 by 6 times integration of 6x plus 1 upon 3x square plus x minus 2 dx minus 11 by 18. So 3 is taken outside. 1 upon x plus 1 by 6 the whole square. And this 25 by 36 is written as 5 by 6 the whole square. Rest of the terms are kept as it is. So now we are going to substitute, rather make use of the formula, that is the derivative of the denominator is available in the numerator. So 5 by 6 times log of 3x square plus x minus 2 minus 11 by 8 into 1 upon 2a, a is 5 by 6, 2 into 5 by 6 log of x minus a upon x plus a, x plus 1 by 6 minus 5 by 6 upon x plus 1 by 6 plus 5 by 6. 1 by 6 plus 5 by 6 is 6 by 6, which is 1. 1 by 6 minus 5 by 6 is minus 4 by 6. Then later on that becomes a minus 2 by 3. So 5 by 6 log of 3x square plus x minus 2 minus 11 by 30 log of x minus 2 by 3 upon x plus 1. And now here we simplify it. That is, I can say multiply and divide by 3. So that finally gives you I equals to 5 by 6 log of 3x square plus x minus 2 minus 11 by 30 log of 3x minus 2 upon 3 times x plus 1 plus c. So the next problem we have numerator is a quadratic polynomial, denominator is also a quadratic polynomial. Generally in such case what we do is, if numerator is a polynomial of degree greater than or equal to that of the denominator, then we use the polynomial division process first, and then further we proceed depending upon the remainder. But in this case, it is a special case, you can say. What we do is, here both are of the same degree, so we can make a small rearrangement in the numerator to get the denominator plus some other term. So for that reason what I do is, I take minus sign out first from the numerator. It becomes x square minus x, and what I want is x square minus 2x minus 3. So I will subtract x minus 3 and add x minus 3. So that becomes x square minus 2x minus 3 plus x plus 3. And now we will take this minus sign inside the bracket by introducing a bracket over here after 3. So that gives you minus of x square minus 2x minus 3, which is nothing but the denominator term, minus x plus 3. And now separately divide it. On separate division this cancels, we get minus 1 minus x plus 3 upon x square minus 2x minus 3 dx. And now we take the separate integration and we call it as equation 1. And here we consider this part for our calculation purpose. So we express x plus 3 as a into derivative of denominator plus b, that is d by a into d by dx of x square minus 2x minus 3 plus b. On differentiating this we get 2x minus 2, and now this a is taken inside, so it becomes a 2ax minus 2a plus b, and we make as one group for this constant part. Now compare the coefficients of like terms. We get 2a equal to 1, which is the coefficient of x, and minus 2a plus b equal to 3, constant part. So that gives rather a equal to half and b equal to 4. Put a equal to half and b equal to 4 in equation 2. So that gives x plus 3 equal to 1 by 2 times 2x minus 2 plus 4. So therefore equation 1, that is the integration, becomes I equal to minus integration dx minus integration of half times 2x minus 2 plus 4 upon x square minus 2x minus 3. Now separately divide here by denominator. So that gives you this term, this expression. And now here we take this integration inside, this minus n also gets in, and along with that these coefficients come out. So minus 4. And simultaneously I have made a small rearrangement in the denominator over here. So what I've done is I've added 1, subtracted 1. So minus 3 minus 1 gives you minus 4. Because just you can observe that this becomes a square minus 2ab plus b square, a minus b whole square form. So it reduces to what? Minus integration dx minus half integration 2x minus 2 upon x square minus 2x minus 3 dx minus 4 integration of 1 upon x minus 1 whole square minus 2 square dx. So here the integration of this is minus x, and this is minus half log of x square minus 2x minus 3, because the numerator is the derivative of denominator, minus 4 times 1 upon 2a log of x minus a upon x plus a. X is x minus 1, a is 2. So 1 upon 2 into 2. These 2 4 get cancelled, and it gives you x minus 3 upon x plus 1. Therefore, I equals to minus x minus half log of x square minus 2x minus 3 minus log of x minus 3 upon x plus 1 plus c. So here what we are given is two linear polynomials, but both are under the same square root sign. So in such cases what we do is we multiply and divide by the numerator expression within the square root. So that means what I have done is square root of x plus 2 upon x minus 5 into x plus 2 upon x plus 2. Observe, this is not the conjugate, it is not a rationalization. So multiply and divide by numerator expression within the square root. So this is to be done whenever you have two linear polynomials, the quotient in the square root. So with this what we achieve is numerator becomes x plus 2 whole square, perfect square, and now the square root will vanish, and simultaneously within the denominator I have multiplied the terms, so that get reduces to I equal to x plus 2 upon root of x square minus 3x minus 10. So now I put x plus 2 equal to a into d by dx of x square minus 3x minus 10 plus b. So x plus 2 equal to a times derivative of x square minus 3x minus 10 is 2x minus 3. Now open the bracket. So that gives you 2ax minus 3a plus b. So on comparing the coefficients of like terms, we get 2a equals to 1 and minus 3a plus b equals to 2. So this gives you the value of a as half, and on putting a equal to half here, you will get the value of b as 7 by 2. You can verify it. So b equal to 7 by 2. Put a equal to half and b equal to 7 by 2 in equation 1. We get x plus 2 equal to half times 2x minus 3 plus 7 by 2. So the problem get reduces to. So numerator part is replaced by this expression. This is a numerator. Now separately divide it. So we have divided by this denominator term. And now take separate integration. So that case this half and 7 by 2 goes, both of them will go out. Therefore I equals to half integration to x minus 3 upon root of x square minus 3x minus 10 dx plus 7 by 2 times integration of 1 upon root of x square minus 3x minus 10 dx. So here in the first part we substitute for this expression x square minus 3x minus 10 equal to t, and the derivative of this gives you 2x minus 3 dx equal to dt. So in simultaneously the second part, x square minus 2 into x into 3 by 2. So I multiply and divide by 2 over here. So now it is in the form of a square minus 2ab. b is 3 by 2, b square is 9 by 4. So b square is added and b square is subtracted. So this can be written as 40 by 9, sorry 40 by 4 multiplied by 4. Then finally added, that gives you 49 by 4. So it becomes 49 by 4. And first part will be x minus 3 by 2 the whole square. Now this can be written as I equals to half integration 1 upon root t dt plus 7 by 2 times integration 1 upon root of x minus 3 by 2 whole square minus 7 by 2 whole square. So this is in the form of 1 upon root of x square minus a square. So 1 by 2 times 2 root t plus 7 by 2 times log of And this is 1 upon root of x square minus a square is log of x plus root of x square minus a square plus c. Plus c is missing, please add that. So finally I equals to, we get here 2 to get cancel, root of x square minus 3x minus 10 plus 7 by 2 times log of 2x minus 3 upon 2 plus root of x square minus 3x minus 10 plus c. So in this time what we note is coefficient of x square is negative. But hardly that affects anything, any part of our process. So we substitute, or rather we can say we put 7x plus 3 equal to a times d by dx of 3 plus 2x minus x square plus b. On differentiating this, we get 7x plus 3 equal to a times 2 minus 2x plus b. Now take this a inside the bracket. This a inside the bracket. So that gives you 2a minus 2ax. And that is rearranged it as minus 2ax plus 2a plus b. Now compare the coefficients of like terms. So minus 2a equals to 7 and 2a plus b equals to 3. That gives you the value of a as minus 7 by 2. When you substitute minus 7 by 2 here, 2 to get cancelled becomes minus 7, goes to the right hand side, becomes plus 10. So that gives you b equal to 10. Now substitute a equal to minus 7 by 2 and b equal to 10 in equation 1. So we get 7x plus 3 equal to minus 7 by 2 times 2 minus 2x plus 10. Therefore the problem changes to. So this is the numerator part. There I will substitute this part. And now separately we divide it. On division I get this expression. And now I take separate integration. When I take separate integration, these constants go out, coefficients rather go out. It becomes minus 7 by 2 times integration of 2 minus 2x upon root of 3 plus 2x minus x square dx plus 10 times integration of 1 upon root of 3 plus 2x minus x square dx. So when we deal with this, what we do is we take the negative sign out and we proceed by completing the square method. So we have done a good number of problems earlier. So first part is as it is, and here negative sign is taken out. So that is, and in this bracket we add and subtract 1. And so it becomes x square minus 2x plus 1 will be x minus 1 whole square. When you open the bracket, this becomes positive. So it becomes plus 1. The other terms are same. These are all the same one as it is. That's the previous one. And this 3 plus 1 gives you 4. And that 4 is written as 2 square. Before that, we substitute for the first part. So in the first part integral, first part of the integral, put 3 plus 2x minus x square equal to t. Differentiate with respect to x. So 2 minus 2x dx equal to dt. So the problem changes to minus 7 by 2 integration of 1 upon root t dt plus 10 times integration of 1 upon. So now this 4 is written as a 2 square minus x minus 1 whole square. And this is in the form of 1 upon root of a square minus x square. Integration of root of 1 upon root of a square minus x square is sine inverse of x by a. So it becomes minus 7 by 2 times 2 root t plus 10 times sine inverse of x means x minus 1 upon a is 2 plus c. So it gets reduced to finally 2 to get cancelled and put back the value of t here. So I equals to minus 7 times root of 3 plus 2x minus x square plus 10 times sine inverse of x minus 1 upon 2 plus c. So a similar kind in this example, if you carefully note, the derivative of this under root expression, that is x square plus 4x, is 2x plus 4, and already 2x is there. So we can make use of that. So that means without going for the usual process, in some cases of this kind, we can think of a different method. So what I have done is I have added 4 and subtracted 4. So 1 minus 4 gives you minus 3. So that means we have directly achieved that a and b values. So now separately divide it and now take separate integration, and this 3 goes out, this part as it is, and here we make the adjustment also. This 13 is written as 4 plus 9, so that this part becomes x plus 2 the whole square, a square plus 2ab plus b square part. And now we put x square plus 4x plus 13 equal to t. Differentiate with respect to x. 2x plus 4 dx equal to dt. So the problem changes to I equals to integration of 1 upon root t dt minus 3 times integration of 1 upon root of x plus 2 whole square plus 3 square. So this is in the form of root 1 upon root of x square plus a square. So that gives you 2 root t minus 3 times log of x plus problem part. That is log of x plus 2 plus root of x plus 2 whole square plus 3 square. On simplifying this, we get the original function. Therefore, I equals to 2 times root of x square plus 4x plus 13 minus 3 times log of x plus 2 plus, this is the original problem, root of x square plus 4x plus 13 plus c. So here what we note is the numerator is a polynomial of degree greater than that of the denominator. So in this case, we proceed by polynomial division, and further we think of the process what we have to do depending upon the remainder. So division process, first I have to take x, multiply by with this x to this term, and that gives you this expression. Then subtract, we get 2x minus 2x square minus 10x minus 26. So the coefficient of x square is minus 2, so I have to get minus 2 here. Minus 2. So that gives you this expression, multiply by minus 2 to this. And then we are going to subtract. When I subtract, these two terms get cancelled, and here what we get is only 2x, and this get cancels. So problem, rather the given expression, this is the integrated of the problem, and that get reduces to x minus 2 plus 2x upon x square plus 6x plus 13. So the meaning of this, further depending upon the remainder, this is the remainder. If the remainder would have been a constant, then we could have directly gone into the completing the square method. Since we have got 2x, so we proceed further by adjustment of the term, because already we have got 2x, which is the derivative of x square. So only thing is that I have to add and subtract 6. Therefore, now we are going to divide here, and that gives you this part as it is, x minus 2 plus 2x plus 6 upon x square plus 6x plus 13 minus 6 upon this. Now take integration inside. When you take integration inside, this 6 goes out, those constant coefficients go out. So this becomes integration of x dx minus 2 times integration of dx plus integration of 2x plus 6 upon x square plus 6x plus 13 dx minus 6 times integration of 1 upon x square plus 6x plus 13 dx. So here we are going to make use of the method of what is called as completing the square method, and this is directly the derivative of the denominator in the numerator. So here the element is made, 6x is written as 2 into x into 3, so it is in the form of a square plus 2ab, b is 3, so b square is 9, 9 plus 4 gives you 13. So now this is in the form of 1 upon x square plus a square. So integration of 1 upon x square plus a square is 1 upon a tan inverse of x by a. So that gives you x square by 2 minus 2x plus log of x square plus 6x plus 13 minus 6 times 1 upon 2 tan inverse of x plus 3 upon 2 plus c. So here it cancels, and that is the problem, rather that is the solution. Thank you.